In the previous lesson or unit, we talked about the machine learning process. And what I'd like to talk about now are the different learning types that are part of the process. So there's two main categories that are part of machine learning. There are some additional categories, but I think for what we're trying to accomplish with asset integrity, these are probably the best to start with. And in this case, we're talking about supervised and unsupervised learning. So supervised learning is learning where we have observations available to us to learn from. Whereas unsupervised learning would be, well, we don't have observations to learn from, but we want to try to discover something useful from it. Supervised learning is further categorized into classification or regression types of models. A classification model is going to be a prediction model for categorical types of targets. And the output out of here is typically a percentage confidence or a probability. And we normally use classification when we're trying to determine threat susceptibility. And there are many other use cases, but this is kind of the main flow for using classification methods. Now, if you go further up to the right here, you'll see there are a lot of different methods or learners or estimators that are available to us to learn a model with. And there's probably, gosh, a good 300 or so plus methods that we could use as part of the process. And I'm going to talk about these models in a future unit. Now, under regression, what we're trying to do here is learn a model for numerical targets. So we have observations that are numerical, and we simply want to find the underlying patterns that help us predict those numerical targets. And we generally use regression for threat severity. In this case, we're looking at corrosion growth rates, CGR, or we might be looking at third-party hit rates or other events per unit time that are just unwanted. With regression models, often we can use similar types of methods. But sometimes there are some purpose methods too for regression. Again, we'll talk more about that. So on the supervised side, we are going to spend a lot of time on classification and regression, classifications for categorical targets, attribute lists and such, and regression is for numerical targets. And as I said, unsupervised learning, we will talk about this, and you can develop unsupervised models. Typically use this for investigating rare or no events, something like SCC, let's say, if you've never experienced on your system, but you'd like to kind of make some kind of determination of susceptibility, you can employ some unsupervised techniques to help you with that. Okay, so let me take you to a little demonstration in the software here. Sometimes this is the best way to show you the differences. Okay, here we go. All right, so let's start with the data. And we're just going to consider at this time classification and regression. And I wanted to show you just a couple of end-to-end examples so you get a sense of what the whole process looks like, kind of on a more detailed and practical level, especially if you're familiar with pipeline integrity use cases. So what you'll see here is this is a table of data. It could be a SQL table or a data frame. And each one of these lines here, each one of these records is a pipe joint. And let's say this information is derived from an inline inspection that's been integrated with other types of data. So each one of these indicators here, in this case, this column here is saying EC binary, and all that means is corrosion was found, yes or no, on that joint. So you can see yes, no, yes, 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 no, etc., etc. So we would use classification then as a method to learn a model to make a prediction of susceptibility to corrosion based on these observations right here. The next column over is ECMPY, and this is mils per year for corrosion. So if you're interested in developing a model for corrosion growth rates, you'd be looking for this kind of a column. It doesn't have to be MPY, it could be depth, it could be something else that represents corrosion severity, numerical, for regression. But this is what we're trying to do. We're trying to make a model, learn a model for either EC binary, yes, no, or for ECMPY. Okay. So the challenge here, and really what machine learning is useful for, is being able to sift through all this data, it could be thousands of records, and trying to find the underlying patterns that influence either the susceptibility or the corrosion growth rate. And if I scoot over to the right, you will see that there's a lot of columns, a lot of predictor data that's available to us. And not all this is required. This just happens to be what the domain experts thought was important for external corrosion. But you'll see that we've got pipe properties, we have data store properties, we have other kind of observed information. And we simply want to extract out the useful patterns of this data and learn some models. So let's go take a look at a couple models and what they look like. So a classification model would look something like this, as far as like presenting the results, back to you, about the model properties. I skipped over the whole model learning because we're going to cover that in several units, but I wanted to show you what the end result kind of looks like. So this is a gradient boosted machine model, and if we pull back the curtains on this thing a little bit, we'll see that one thing that's useful you get out of the model learning process are the weights. These weights represent it's a linear representation of the nonlinearities within the model itself, because the models can be quite complicated. There's a lot of interactions going on, and they're not just straight scoring like 0 to 10 and adding things and subtracting things. In many cases, there's a lot of complex relationships, and all this is showing us here is a representation of the potential influence of the different predictors on the prediction target. So this is one of the first, probably most useful things that comes out of the model itself. It's giving you some kind of idea of how important the data is to the particular target. This is a rock curve on the right, and what this is showing us is the ability of the model to find the positives. So in this case, where corrosion really is, as compared to the rate of false positives. And this blue line here in the center is a coin flip. So what you're trying to do with your rock curve when you're learning a model is to have a red curve that reaches up to the top left as quickly as possible. Down here in this table, this is a grid of hyperparameters. So most methods have hyperparameters that need to be tuned. And again, we're going to talk about this. But we use a grid search to find the best parameters for the best fitting model. And that's all this represents here. And then to the right is a list of all the predictors that feed into this particular model. So this is generally what you get as a model output for classification. And since we're using an R platform, the underlying model here is really just a transportable object that we can open up and take a look at later and deploy in different kinds of systems. Now, once we have a model, we would apply it to other pipelines. And that's what I'm showing you right here. So this is showing you the results of the application of the model. And on the bottom x-axis here, we have the probability or confidence or level of susceptibility to corrosion for all the pipe joints that are part of the prediction data set. And then we have the individual pipelines. And this is a box plot. It's just showing us that pipeline number 1 has the highest mean with a lot of outliers going to the left and to the right. But it is showing that this is the most susceptible pipeline to external corrosion. And you can use these types of outputs now to prioritize inspections and focus in on outliers, because you might have a low mean like pipeline 6, but you got these outliers out here. Each one of these dots is a pipe joint with a high probability of external corrosion. So maybe you want to mitigate these areas. Okay, so after you have these predictions, you might want to go even a step further and take a look at the sensitivities of a classification model. So here what I'm showing you is that same pipeline number 1. Oh, no, this is number 4. And this will work too. But this is pipeline number 4, and these are the joint by joint predictions of external corrosion susceptibility. And then if you look at individual points, which is this black line here, you can get an idea here on the right of the sensitivity or what makes up the predicted value. So you can make these models, any of these models, very transparent and get the end results out pretty quickly. Now let's take a look at a regression model. So recall that we were learning on a column for external corrosion mils per year. And if we want to take a look at a regression model, same kind of presentation, and this is what it looks like. We use the same method, a gradient boosted tree, and you can see that here are the coefficients or the weights that came out of the model itself. We typically like to use a unity type plot to look at performance of the model. So this is showing us joints of pipe. Each dot is a joint of pipe, what its predicted MPY is versus its actual. You'll see we have the same kind of grid optimization table right here. And then we have a list of our predictors. Okay. So one of the challenges that you have when you're going through the machine learning process is most methods have a lot of levers that you can pull. So there's a lot of opportunities for improving the model. And one way where this is just gradient boosted trees, this is showing you that there's 4 different parameters that we can vary and see how well the model will improve or degrade. So in this case, it's giving us hyperparameters for shrinkage, interaction depth, minimum observations in trees, and we use this grid search to find the best model. And again, we're going to get into this in more details, but this is basically how all models look. Okay, and if we do the same thing and look at the predictions, applying the model back to other pipelines, you'll see now we have on the x-axis the corrosion growth rates, and for each pipeline, you see how they're sorted by the mean corrosion growth rate. And it's interesting to note, before we had pipeline number 1 being most susceptible, but we can see pipeline number 2 has the highest severity growth rate, even though it's not as susceptible. And then you look at pipeline number 5, it's kind of like low on the list for corrosion growth rates, but it's got a lot of outliers that might need some investigation. And then the last thing would be the sensitivity. So it's the same kind of approach. And again, I'm going to share the technical methods behind here so you can get familiar with them and use them in your practice. But here you can see joints of pipe. The axis here is corrosion growth rate, MPY. And you can see this one joint of pipe was selected, and here's what makes up that prediction. So now you have an idea of what is actually influencing higher or lower levels of corrosion growth. So that is really the overview for the types of machine learning we're going to be taking a look at: classification and regression. I didn't show you unsupervised learning, but we'll cover that in a use case. But this should cover this particular unit, and we'll move on to the next one.